Very good morning, dear students. This is the video of two-port networks in which we are going to study about short circuit admittance parameter, that is also called as Y parameter. This Y parameter equation is actually based on this KCL equation I have written over there. We have completed Z parameter. And now we are going to complete and study short circuit admittance parameter, and very popularly and in short form known as Y parameter. Now the analysis is exactly same as we have done in Z parameter. This is the equation I have written over here. See this. This is equation number 3 and this is equation number 4. We have discussed in Z parameter by taking two equations. Now in this Y parameter I am going to derive all the necessary similar things that we have derived in Z parameter, that is transfer admittance, driving point admittance, and we'll see that how we are going to treat the port. This is your port. Let me draw the port once again for you. This is your port. This is port number 2. This is plus minus voltage V2 defined. This is I2 inflow towards this network. This is port 1. This is port 1, and this is your V1 defined here, and this is inflow of current 1. This is inflow of current 1. Now Y parameter equation is based on KCL equation. That means what? It will have current equation. So simple. So I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. They are dependent variables. I1 and I2. Why? Because the value of I1 and I2 is depending. The value of I1 and I2 is depending on the value of V1 and V2. Here, this is your V1, this is your V1, and this is your V2. See this. Now, so we can say that this is V1 is independent variable, V2 is independent variable, and the dependent variable is I1 and I2. I1 और I2 की निर्भरता V1 और V2 पर है. V1 और V2 स्वतंत्र वेरिएबल है. ओके. Y11, Y12 और Y21 और Y22 are the admittance parameters. What are these? These are admittance parameter. I am writing like this in matrix form. These are admittance parameter. What are these? These are admittance parameter. Admittance parameter. Initially, In Z parameter, we have seen Z11, Z12, Z21, Z22 like this. We have seen Z11, Z12, Z21 and Z22. These were what? These were impedance parameter. We have seen this. Okay. Now to determine this Y parameter, what we have to do? We have to actually do the same analysis as we have done to determine the value of this Z or the impedance parameter. Now see what we have done in to determine the value of Z11, likewise Z12, likewise Z21, and similarly the value of Z22 was determined in the similar fashion. Just have a quick recap. See this. To determine the value of Z11, we have opened port 2. By opening port 2, we have actually ensured that the value of I2 is 0. Like this. See here. Similarly, to determine the value of Z21, we have ensured that it is only determined at the condition when I2 is 0. Why I2 is 0? Because we have chosen port 2 to be open. When port 2 is open, voltage will exist. Of course, voltage will exist. It is existing. Open circuit voltage always exists. We have seen this. We have done a lot of analysis. We have done a lot of explanation over this. Open voltage exists across the terminals. But as far as current is concerned, current never exists in open circuit. It always needs a closed medium, a closed path to flow. Okay. Now this was the Z equation. The Z parameter equation was based on KVL. See this. Okay. So it was based on KVL. See this, V is equal to IR form. So we have done what? We have kept voltage as it is, and we have zeroed current. Likewise, in this Y parameter, when we are having KCL equation, we'll keep our current and will ensure that voltage becomes 0. Let us understand how it is done. This is your port. This is your port. Okay. This is port 1. This is port 2. This is 1 and 1 dash. This is plus and minus. Voltage V1. Current inflow I1. This is current inflow I2. This is plus, this is minus, this is V2. Okay. Now we are going to determine this Y parameter. We are interested to determine Y parameter. Now we have to short circuit the port 1 or 2. We have to short port, either port 1 or either port 2. In first case, we'll short port 1 and we'll calculate the remaining Y parameter. Okay. In the next process, we'll short port 2. We're just shorting one port. the another port will remain as it is. The another port will remain as it is. And we will calculate same thing y parameter. We are going to, we will short one port while other remains, while other port remains same. Let us short port number 2. Let port 2 is short circuited or shorted. It is short circuited. It means what? If port 2 is short circuited, it means what? We'll have V2 is equal to 0 and I2 will exist. I2 will be, but what will be the value? We'll see. So under this condition, under these conditions, we have from this equation, see this, from this equation, I1 is equal to y11 v1 plus y12 v2. If v2 is made 0, the whole term will become 0. So we are having what? We are having I1 is equal to y11 v1. So sorry, y11 will be equal to y11 will be equal to I1 upon v1. See this. See this. This is y11 v1 plus y12 v2. This is my equation number 3. I have taken this equation from this equation number 3. Okay. Now see this. V2 is made 0. So V2 is made 0. It means what? This whole terms will become 0. That implies I1 is going to be, I1 is equal to y11 v1. That implies we can easily have the value of y11 here, which is I1 upon v1 under the condition when v2 is 0. This y11 is called here driving point admittance at port 1. This is called driving point admittance, and where it is? It is defined, v1 is defined as port 1, I1 is defined at port 1 likewise, and this v1 is also defined at port 1, so it is at port 1. Okay, this is also called as input admittance. Please make it a note. This is also called as input admittance. Input admittance. I'm going to write it in full form so that you may see it very clearly. Input admittance. Okay. So what we have done, we have actually shorted one port. Now P2 is shorted, so we have calculated y11. Let us see the another thing we can have. This is also V2 here, so it can also be 0. So we can have from equation number 4. That is, equation number 4 implies that we can have I2 is equal to y21 v1 plus y22 v2. When v2 has been made 0 for short circuited, it will become 0. So we have I2 is equal to So this, when V2 is 0, so I2 will be Y21 V1, and Y21 can be written as I2 upon V1 under the condition V2 is 0, because we have short circuited port number 2. So port number 2, the voltage has become 0. Okay, this is called Y21 is equal to I2 upon V1. This is called transfer admittance. This is called transfer admittance. Now, port number 1 is short circuited. Port number 1 is short circuited. So what will happen? Just see. If port number 1 is short circuited, it means what? V1 will become 0, isn't it? When it is short circuited. So let us write this. If port number 1 is short circuited, V1 will equal to 0. From question number 3 and 4, we have Y12 is equal to I1 upon V2 when V1 is equal to 0. This is called transfer admittance. This is called transfer admittance. And Y22 is equal to, see this, from where I am getting this? I am getting this from equation number, either it is from equation number 3 or equation number 4. Definitely Y22 is take equation number 4. So I am taking this from equation number 4. When V1 has become 0, so this entire term will become 0. So I2 will be equal to Y22 into V2. Okay. So I am writing from here. So Y22 equal to I2 upon V2 when V1 is equal to 0. This is called driving point admittance. This is called driving point admittance, where at port number 2. Why at port number 2? Because I2 exists at port number 2, V2 exists at port number 2. Okay. This is also called as output admittance. See this unit is, the unit is mho. It is represented as this. Y22 unit is mho, and the unit of Y12 is also mho. And the unit of Y21 is also mho. Unit is MHO, mho, represented as like this. The inverse of ohm or ohm inverse, you can also have ohm inverse. The unit of Y11 is also mho or ohm inverse, or simply like this. Let us proceed for matrix representation. This can be matrix form, can be represented as I1, I2 is equal to Y11, Y12, Y21, Y22 and V1, V2. We are going to calculate determinant of admittance matrix. This is determinant of admittance matrix, which is delta y is equal to y11. This is multiply this element y11 into y22 minus multiply then this with minus sign. So it is y21 into y12. Okay. Now, for any system to become reciprocal, for reciprocal network, the condition is y12 must be equal to y21. This condition must be satisfied, otherwise that network will not be a reciprocal. Okay. And another one is the condition for electrical symmetry. For electrical symmetry, that will be equal to y11 is equal to y22. This is the condition for electrical symmetry. Okay, let us understand how the equivalent circuit is drawn using Y parameter. That is, equivalent let me write it very clearly. That is equivalent circuit using Y parameter. You may be remembering, you may recall that we have also drawn equivalent circuit using Z parameter. Okay. For the Z parameter, we are having some controlled sources and some series parameter connected to that. Now, in This equivalent circuit using Y parameter will also have controlled sources, current control sources, voltage control sources. It will depend. We'll see. See the equation. This is equation. Equation number 3 and 4. Let us understand from the basic of equation given. See this. This is I1. I1 is given. Y11 V1. Suppose V1 is your voltage. Of course, it is voltage. So I1 is Y11 V1. It is voltage controlled current sources. Okay. Also, if I1 is equal to Y12 V2, so it is also voltage controlled current source. The output is current, but its output is depending on the value of initially the value of V2 voltage. So in this equivalent circuit will have voltage dependent current source or voltage controlled current source. See this. This is your for port number 1. This is Y11. See this from equation number 3. From equation number 3, this is Y11, and this can be termed as voltage controlled current source. Voltage controlled current source. How the current sources are drawn? It is drawn like diamond shape. This is voltage controlled current source. The source is current source, so it is like this. It is Y12 V2. This is plus or minus the voltage V1 from here between these two terminals, and current I1 is inward. From port number 2, see this. Let us understand from the diagram. This is your port number 2. This is a port number 2. V2 is there. I2 is inflowing. Now equation number 4. See this equation number 4. I2 is equal to Y21 V1 plus V22 V2. The voltage V2 will be across the terminals. The voltage V2 will be across the terminal. This thing, see this parameter Y21 V1. This is voltage controlled current source. Okay. So it can be drawn as like this. In shunt parameter we'll have, what is this? This is Y22. From port number 2 we are seeing this, and this is your voltage controlled current source. This is Y21 V1. This is I2. This is voltage defined from here V2. So this is your equivalent circuit diagram. We have drawn this by using Y parameter.